This is a video from Math 120, section 2.8. We're going to look at derivatives and second derivatives and try to figure out what it means on our graph from those perspectives. So we want to sketch a possible graph of a function f that satisfies the following. The derivative is greater than 0 from negative infinity to 3. So negative infinity to 3, the derivative is greater than 0. The derivative is less than 0, so you want to think slope. The slope is less than 0 on 3 to infinity. So the function is going down from 3 to infinity. And this is our function, not the derivative. The second derivative is about concavity and inflection points. So looking at our graph here, we have concave up. This looks like a smile from here to there. And we can kind of get rid of part of the graph. You can see the smile from there. If I cover up that, I can then see that there's a frown, upside down, concave down. And then if we go to the next inflection point, we can see that there's concave up here. So you want to think about the concavity and the inflection points. So this says f double prime of x is greater than 0. That's concave up. The second derivative is positive. It tells me concave up, and this is, and it is over here again, negative infinity to negative 6. And 6 to infinity. That's exactly what the graph looks like. The second derivative is less than 0. That's concave down. So that's the part we said from negative 6 to 6. So there's an inflection point at both negative 6 and 6. And then the limit as x goes to negative infinity is negative 2. So this is end behavior. So negative infinity, it's flattening out at negative 2. And then x goes to infinity, it flattens out to 0. So then you just answer a few questions about those concepts. So the rate of the population increasing means slope. So at what point is the rate of the population increase the greatest? Where is this the steepest? On what interval is it concave down? Concave down forms a frown. So concave up, concave down. Concave downward, they ask up and down here. And then the inflection point is where that concavity changes. For a more wiggly graph like this one, you have more ups and downs and concaves ups and downs and inflection points. But you can see this concave down, inflection point, concave up, inflection point, concave down, inflection point, concave up. On the first graph we looked at, they gave us the graph and talked about the function. Here they are giving us the information about the function and they want us to find the graph. So it says that 3 of the derivatives are 0. That means that it has a flat slope for 3 of the derivatives. It has a max or min. It tells us where the function's actually going up, it's greater than 0, and where it's going down, less than 0. It tells us where it's concave up, that means a smile, and concave down is frown. Concave up forms a cup, concave down forms a frown. For this last one, they tell us that f is actually the derivative, and we want to find what's called an antiderivative. What do we take the derivative of to get this? What do we take the derivative of to get this? Well, we can see that there has to be a high point or low point there. So it was positive going up, high point or low point, and then it's going down. So which one of these graphs does that? F is the derivative. You want to think about it's the derivative of some graph. They're saying this is actually the derivative function. So at where it hits 0 on the axis, there's going to be a max or min. And in this case, we know it's a max because it was up before and down after.